Greetings! This is my electric motorcycle conversion. This conversion was done on a budget with the aim of being a low-cost commuter machine for the city. It started life as a 1985 VF1000R sport bike. Before anybody starts coming after me for ruining a classic bike, there was nothing left of this machine other than a blown motor, incomplete bodywork from a 750 Interceptor with a rusted out tank, and title issues. It was not a restoration candidate. Once the bike was stripped down, chassis rehabilitation was done, things like replacing bad bearings and fork seals and getting the brakes operational. What took the longest was just figuring out how I wanted to power it. I was fully aware of the electric vehicle's self-fulfilling prophecy problem. I don't want to put a lot of money into something that's just going to suck, so I buy cheap components and then it sucks because the cheap components are no good. This process went through many iterations. At one point, I picked up an inexpensive 36-volt DC forklift motor. It wasn't a bad motor, just the more I looked at it, the more I wasn't sure I wanted to use it. It's on the big side, and low voltage is not great unless you run it through a transmission, which I did investigate, but ultimately rejected because the whole idea just took up too much space in a motorcycle frame. Thankfully, I waffled on this decision long enough that technology advanced to the point where a somewhat economical option solved my weight and size problems. I ended up picking a conversion package from AliExpress that included a QS165 motor, bar driver ND72490B motor controller, and assorted other electronic parts that my conversion would need. QS motors are fairly popular in dirt bike conversions and have a reputation for being durable, and that the 72 volt 5000 watt rating is on the conservative side. The controller is rated for 5 to 6 kilowatt motors and a max 720 amp DC power draw. With that part of the power plant sorted, the next big waffle was batteries. Once again, I was up against budget versus quality and capacity. In experimenting with electric assist bicycle systems, I learned that in the battery world, you really do get what you pay for. I'd found some lithium batteries that were advertised as high capacity and fairly low price, but I had been burned before, so I was hesitant to gamble. I started looking at various lead acid batteries that would work, but to get any sort of capacity, the pack got large and heavy quite quickly. Then, while lurking on various forums, Nissan Leaf batteries were mentioned. I looked into it, and there are many pluses for what I wanted to accomplish. The modules bolted together, no soldering on volatile batteries that might object to heat in the wrong location. Each module is 7.2 volts. Just stack as many as you need, and it's good to go. And the price is reasonable. A bit more interneting, and I found GreenTech Energy Second Life Energy Solutions. I ordered up enough modules for the order to be split into 4 boxes, and FedEx sent one to the local store to be picked up as I requested for the entire order, and dropped the other 3 boxes in the carport for all the neighborhood to see. Once bolted together, I picked up an ANT BMS for 8 through 22 cells and 130 amps. Once I found out that the included wiring schematic was incorrect and wired it up properly, it worked just fine. I then found a gearing calculator and put in a top speed of 55 miles per hour, and it spit out that I needed a 70-tooth rear sprocket. I found Rebel gears, and they made up a custom sprocket much faster than I expected for a decent price. The end result is what I was after, an electric motorcycle for commuting to work and back. Top speed per GPS app is 53 miles per hour and a range of just over 20 miles. While these are not amazing numbers, they are perfect for what the bike was built for, getting to work and back home. It is actually lighter than it was with the gas motor, and with top of the line for the 80s suspension, it handles pretty good. There are moments here and there where I would like some more power, particularly getting off the line. I think the main limitation is using recycled batteries. They just can't provide the amp draw. The other possibility is tuning the controller more towards my liking. Counting starts and stops, changing ideas, and life getting in the way, this conversion took years. Time actually working on it, maybe a few months. As far as costs, I must confess, I didn't do a very good job with record keeping. but off the top of my head, somewhere in the neighborhood of $2,000 to $3,000. Similarly, spec commercially available options here in the United States start around $5,000 and go up very fast. So I'm ahead on that front. However, the commercial options do offer better performance and range. Future plans are to integrate the 110-volt charger into the bike for more convenient charging and eventually upgrade the battery to get better range and performance. But for now, I'm just enjoying getting around on a bike that I built.